Basic Factoring Review Algebra 2 Common Core. So this first video is on factoring methods that at this point you really should have mastered a long time ago. You shouldn't even need to watch this video, so let's hope you don't, but in case it's been a little while since you factored, I wanted to make it just to refresh your memory on some of the basics, because this year you're gonna, and these factorings that I'm gonna show you in this video, you've been doing every year for the past several years. But you are going to learn some new factoring methods this year and some very difficult factoring methods this year. And if you don't have a good foundation with these basics, then that's going to make things a lot harder. So even if you are pretty confident on this, I still recommend you watch the rest of this video and make sure you have a really strong foundation when it comes to some basic factoring styles. So one of the basics we're going to learn today is talking about a GCF, and this is how we always need to begin factoring, is looking for a greatest common factor. And basically what that means is whatever expression we're factoring, we want to look at every part of that expression and ask, is there something in common? And looking at 2x squared y minus 4xy cubed, there's multiple things in common between these two. And now it's not always a binomial. This is a binomial. It could be a long chain with 15 different terms, but if they all have something in common, they could all be divisible by 2. They all have an x or something like that. Then we can divide that out. We can factor it out. Now, throughout the chapter, I'm going to be referring to divide and factor as kind of the same thing. You know, like when you factor, we say 10. 10 I can think of as 5 times 2. Well, that means that 5 and 2 are the factors of 10, things that multiply to it. And that's exactly what we do when we factor something. If you factor an expression to, you know, two pieces, well, those two things multiply back to the polynomial. So division and factoring, you really have to get it into your head that that's the same thing. So what's in common here? Well, first we look at the numbers 2 and 4, or negative 4. They could both be divisible by 2, and they both have an x. Now I want to take the lowest exponent that have in common. So we have two x's here, one x here, so I can only take 1. I can't take 2 because this doesn't have to. It only has 1. And the same thing for y. This has 1y and this has 3, so I can only take 1. So that's what's coming out. And it's coming out through division. So what's left over, the quotient piece, quotient is the result after division, is when I divide 2xy from this. 2 divided by 2 is 1. I'm not going to write it. X squared divided by x is x. Y divided by y is 1. So all that's left over is an x. I could write 1x if I'd like, but usually we don't write the 1 unless the only thing there is 1. But if it's going to be 1 times x or something like that, again, I'm not going to bother to write it. Negative 4 times 2 is negative 2. X divided by x. Again, a lot of people like say, it cancels. Well, what do we mean by it cancels? What really happens is x divided by x, even though they're variables, anything divided by itself is 1. So it would be times 1. But again, I'm not going to write that times 1 because I know that negative 2 times 1 is negative 2. And it's kind of silly to write times 1 next to things because they don't really do much. So we say cancel, but really it doesn't disappear. It divides to 1 times what's already there. Y cubed divided by y is y squared. And when we divide variable exponents, get subtracted. When we divide a common variable, we subtract the exponents. And so these are this and this. These are the two factors that came from this expression. And just like 10 can be factored to 2 times 5, if I multiply these, which in polynomials that's distribution, if I distribute, I'd be back to where I was. So that's greatest common factor, and this is where you should always start. This is the first thing you look for. First thing you look for. Because you're going to see some really long factoring styles and some combined factoring styles, but the first thing you look for is greatest common factors. The first question you ask yourself, is there anything in common? And it has to be all or nothing. If it's something like 6x squared plus 3x plus 5, there's no greatest common factor here. Yes, these two terms both have an x, but all three terms don't have an x. These can be divided by 3, but this can. So it has to be all or nothing when you're doing greatest common factor factoring. But that's the first thing we look for. Then the next two basic styles are what we call a trinomial. And this is a trinomial. It's called a trinomial because it has 3 parts. 1, 2, 3. We refer to the coefficients as a, b, c. And so in this case, a would be the number 1, It's not 1x squared, it's just 1. B is 5, and C is negative 24. It's just the numbers A, B, and C. And so it's got 3 pieces, and the prefix tri stands for 3, so it's trinomial. Again, before I even get to trinomial factoring, I want to see, is there anything in common? These two have an x in common, but not that. Nothing I can divide them all. There's no GCF. So now you're ready for trinomial factoring. And the way trinomial factoring is it factors to a product of 2 binomials. So we set up 2 parentheses. And this is basic trinomial, and what that means for a basic trinomial is that a is 1. If this was 5x squared or 2x squared or something like that, it'd be a little bit more advanced. And so we'd have to learn another method, and we'll see that in the next video. But for a basic trinomial, because this is basic factoring review, a is going to be 1. And what we're looking for, the numbers that go in here with their x's that I already put in, is numbers that multiply to the c term and add to the b term. So you could think am like the time. Like right now it's 1:34 p.m., but you know about am is the morning. So a and then m. Sometimes people like to reverse that, but it's not ma, it's am like the time. So adds to 5, multiplies to negative 24. You want to start by what multiplies to negative 24. Now the fact that it's negative means you're going to have one positive, one negative. They're going to be different signs. If 2 numbers multiply to negative, they're opposite signs. Multiplies to negative 24, adds to 5. How about positive 8, negative 3? Multiply to negative 24, adds to 5, so that is it. Now you might have to spend some time thinking about that, and there are some other tricks you can use on your calculator and things like that, but x plus 8, x minus 3. Again, I'm kind of flying through this and not spending too much because I really just want to refresh your memory. You should not be learning this for the first time. If you are, then you're in trouble. But of course, if you ever have questions on this, ask me in class, and you can certainly Google basic factoring and you'll find millions of websites explaining how to do this stuff. Next, we'll look at what we call a DOTS, a DOTS. And DOTS is an acronym that stands for difference of 2 squares. So a difference of 2 squares. A DOTS is always a binomial, so it doesn't look like a trinomial. A trinomial's got 3 pieces, DOTS has 2. And again, there's no greatest common factor. There's nothing in common between these. Now, we are going to get to something called factor completely, which combines several of these methods together. But at the basic core, we always look, first, is there a GCF? No. Second, are there 3 terms or 2 terms? If 3 terms, it's probably a trinomial. 2 terms, it's probably a DOTS. And the difference means there has to be a minus between. Difference means subtraction. Difference of 2 squares, meaning this has to be a square and this has to be a square. Square variables have even exponents, so like x to the squared, x to the 4th, 6, 8, 10, those are all square variables. The large numbers, constants, and coefficients have to be square numbers. 1, 4, 9, 16, 25, 36, 49, 64. Like 7 times 7 is 49, so 49 is a square term. And I'm sure very familiar with squares at this point. Factoring a difference of 2 squares, first of all, identify it is a difference of 2 squares. Also factors to the double parentheses like the trinomial does. And the fact that it multiplies to a negative means we know they're going to be different signs. And it doesn't matter which one's first, which one's second. And then the pieces around the signs are going to be the same. And you could think square root. The square root of a squared is a, and the square root of 9 is 3. So we have a minus 3, a plus 3. That would be a difference of 2 squares. They're going to get more advanced than that, like let's say 25x squared minus 16. That's going to factor to 5x plus 4 and 5x minus 4. Again, opposite signs in the middle. The square root of 25x squared is 5x, and the square root of 16 is 4. There's no GCF. It's not a trinomial. It's only 2 terms. It's got to be a minus between. Now, if I threw a plus sign in there, it's not factorable. And you will see some expressions that are not factorable. And when we get into setting them equal to 0 and stuff, solving like that, a lot of times that means that they're imaginary, and we're going to learn about what that means. So if we put it together, we often see expressions that say factor completely. And what that means is it's a combination of multiple factoring methods. It could be a DOTS several times. It could be a GCF and trinomial paired together, a GCF and a DOTS paired together. It just means you probably have multiple factoring styles or a factoring style multiple times. So we always look for GCF first. The first thing you look for, GCF. So looking at this expression, I recognize that they do have actually a good amount in common. They are both divisible by 3. They both have an x and a y. So when I take that away, the first term I'm left with x squared. 3 divides to 1, the y's divide to 1. I take 1x away, I'm left with x squared. Then when I divide 3 from here, I get negative 4, and the rest is gone. Now, when you're factoring completely, you always want to take a second look, because there's always, well, shouldn't say always, pretty much always, something else that needs to be done. We did GCF, that's great, but take a look at what's left over. It's a dots, a difference of 2 squares. So it started off as a GCF, and now it continues to a dots. The GCF stays part of the problem, but now I can factor the dots to x plus 2, x minus 2. And the whole thing there is factored completely. If we were then to set equal signs next to these things and solve, all we need to do then is we still start by factoring, but then we go a little bit further. The key for solving expressions like this is that it always has to be set equal to 0. So a lot of times it's not set up like that, but always think set equal to 0. In this case, it was set equal to 0 for you. So next thing we do is factor, then solve. So if I factor x squared minus 8, that's going to give me x plus 8, x minus 8. Keep it equal to 0. Once it's factored, you set each term equal to 0. So x plus 8 equals 0, x minus 8 equals 0. And then you just solve these little mini linear equations. Minus 8 on both sides, I get x equals negative 8. Add 8 both sides, x equals positive 8. And so it is 8 and negative 8. We could actually write that as plus or minus 8. Now, there are times where sometimes answers are going to reject, but we're not there yet. So don't worry about that. Nothing's going to be rejecting just yet. One more, do a quick example here. Let's see what we can do here. A lot of times people see x squared and they automatically think trinomial and dots. But look at this. There's only 2 pieces here. It's already set equal to 0. So it's not a trinomial. And it's not a difference of 2 squares because this x has an exponent of 1. This is a GCF problem. They both have an x. I take that out, left with x minus 4 equals 0. Set both factors. Again, this is a factor too, and I get 0. And x minus 4 equals 0 gives me 4. So I get solutions of 0 and 4. All right, so that's a lot of basic factoring stuff, things hopefully you already knew, but if not, hopefully it's a refresher. And if you did know it, hopefully you understand it even better now. We'll practice this, and then we're going to get into some way more advanced factoring very, very soon. See ya.